Hi, class A. We're on section 4.2 about quadratics, day 2 of chapter 4. So today we're going to talk about quadratics. Sometimes you'll have to complete the square. We'll talk about vertex, max, min, opens up, down, symmetry point, axis of symmetry. It's going to be the bomb diggity. So get ready. Let's jump in. So looking here, we have two quadratic parabolas for us to look at. Couple of things we want to talk about is the direction. It opens up if the a value is greater than 0. So if this value in front of the x squared is positive, you'll open up. If the value in front of the x squared is negative, you're going downtown. The vertex is always that changing point. So it's increasing, increasing, increasing. Oh, vertex, and then you flip direction. The axis of symmetry is going to be this vertical line going through the vertex. It's called symmetry for a reason. What's on the right side is going to be symmetric to the left side. Okay, that will always happen. So you should have two perfectly shaped U's because they are symmetric. Let's jump on it. We're going to complete the square. Hopefully if you've learned this before. If not, I'll give you a little crash course right now. But we're going to use completing the square if you're in standard form. So right now, this is standard form. We need to graph it. The idea here is to use the technique of completing the square. This will enable us to obtain the required graph simply by shifting this normal y equals x squared graph, a normal quadratic parabola. We begin by writing the given equation. Notice here I left a little bit of a blank. You will want to leave a blank because completing the square, right there we're going to add your b divided by 2 value squared. Okay, this is like the go-to completing the square formula you need to have. Okay, heading back to our equation, well, this is the a value, b value, c value, nothing crazy. So what I'm plugging in is actually going to be negative 2, that's the b value, divided by 2, so that's negative 1, negative 1 squared. That goes right here. Notice that goes right there. Well, you can't just add 1 and think you can do that to every equation. You have to be even. So if you're adding 1 right here, you have to also subtract 1. Keep this equation balanced. Big part right here. A lot of people forget to subtract that 1, and it's not a balanced equation anymore. Once you get to here, the whole point of completing the square is to get this as a squared term. So if you're able to write this as something squared, so b plus 2, then you know you completed the square properly. You got that square. Well, am I able to factor this into 1 or 2 of the same terms? Well, yeah, I can simplify this to x minus 1 squared. X squared minus 2x plus 1 is the same thing as x minus 1 squared. This is now in a form that I can graph and just change a little bit from the basic y equals x squared graph. Okay, that parabola. As you can see, it's right next to us right here. I'm going to show you how to find all of these points, and then we'll practice. First element we want to find is always the vertex. So vertex is key. We need to know where does our graph change shape. Well, it's going to change shape at the opposite of the value being squared, so 1, and then the same as that c value, so 1, 2. Just like we did in point slope, just like we did in translations and reflections, everything builds, and here we're going to use it. So that's our vertex right here. we're going to also try to find the x and y intercepts to show where they come from. So x-intercept, we'll start there. X-intercepts means where does it cross when y is 0. I'm going to take the function we have. Instead of putting y, I'm just going to put in 0, and I'm going to solve this. I'll subtract over the 2. I'm going to zoom in. We have x minus 1 squared. How do you want to do a square with a square root? Uh-oh, spaghetti-o. I can't take a square root of a negative. This would be imaginary. And that's okay. All that's telling you is that there's actually no x-intercept. Can we verify that in the graph? Well, yeah, it actually never crosses here. When y is 0, it doesn't cross. That makes sense, so I did that right. Let's now find the y-intercept. That's the opposite. That's when x equals 0. So go to your function, plug in 0 for x. So I'm going to get y equals negative 1 squared, which is 1. 1 plus 2 is 3. So that's the point 0, 3. Let's see if we can verify it. 0, 3 right here. We know our axes of symmetry is this dashed line through the vertex. Notice the equation for it. It's x equals. Because it's that vertical line, you need to make sure you write the equation. X equals 1, because that's the x value of your vertex. Because this is the axis of symmetry, we also have this point right here. I could definitely find it by plugging in 2, solving, and you get 3. But notice, it is directly symmetric to the y-intercept. This was 0, 3. That's 1 unit away, so 1 unit away to the right is 2, 3. This is what's called the symmetric point. Okay, just one point that is symmetric to the other side. No algebra needed. You can just look at it based off being symmetric. There's your point. Okay, a lot of vocab, a lot of formulas. Let's keep going. The graph of y equals ax squared. The graph of y equals ax squared is a parabola, you know that, with a vertex at the origin. It doesn't shift right or left, it's right at the beginning. And it's a similar shape to y equals x squared. So this is the one that's black, well I guess now yellow. That's like the home base, that's the parent function. Everything else varies from that. We talked about part 2. It opens up if a is positive, down if a is negative. A is that value in front of the x squared. That tells you up or down. We also can talk about if it's narrower or wider than this normal function. Notice if a is greater than 1, absolute value of course. If it's greater than 1, for example, if it's 2, it's going to be smaller, it's going to be narrower. If a is 1/2, notice that is less than 1, it's that fraction, it's going to be a little bit wider. So use that fact for number 3, and let's try to use all that to do a sketch. First thing I'm going to do for part A, I'm going to write the vertex. I'll actually write out the word vertex. We know that by looking at the equation, we're going to do the opposite of what value is being squared. And there's actually no value being added or subtracted. You can think of it being like a 0 if you want. And it's going to start there. That's my starting point. It will open up because the 3 right here is positive. And we have to notice it's a 3. So that is bigger than 1. So it's actually going to be a narrower graph compared to the basic function. I'm going to start graphing. 1, 0. I know it opens up and it's going to be narrow. Well, XY table time, peeps. Let's go. I like to put my vertex in the middle. Pick a value to the right, maybe 2. Pick a value to the left, maybe 2 of them, whatever, to get a good graph. So I'm going to pick 0 and 2. That's a point to the right, point to the left. If I plug in 0 to this beginning function up here, I would get 3 times 0 minus 1 squared. That would be 3 times negative 1 squared, 3 times 1, 3. So I have the point 0, 3. If I plug in 2, 3 times 2 minus 1 squared is 3 times negative 1 squared, which is 3 times 1, which is 3. Now realize, because of this axis of symmetry, and I would like you guys to draw those axes when possible, this is actually the symmetric point, so I didn't have to plug it in to see. It would have actually come out anyways, because it's symmetric to that y-intercept. Let's check. Does it have a vertex of 1, 0? Yep. Does it open up? Yep. And is it a little narrow compared to the normal function? Check. Next one. Same steps. The vertex is going to be positive 1, 0, because you do the opposite operation. This time it's going to open down. Okay, this negative 3 tells me it should open down. Now, we have to look if it's going to be narrower or wider. Well, the absolute value of negative 3, is positive 3. So that falls in this narrow column. That's why it's absolute values. We're going to find a narrow graph. Let's see what we got. We'll start here. It should open down and it should be narrow. XY table. I don't know anything else. Put your vertex in the middle, a point to the right and left. Take a quick moment, make sure you plug these in. This is what you should get. Graph in that axis of symmetry, por favor. And there is your graph. It has the correct vertex, it opens down, and it is narrow. Last one, your turn. Let's pull it all together. Let's see what you can do. I'm going to get you started, and I would like to see this problem when you come to class. Hintity, hint, 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 hint. Make sure you show all work. Make sure you have every information written down. I will be checking this in class. Hintity, hint, 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 hint. Okay, so I'll get you started though. Here's your equation. We have to first complete the square to find the equation, then we can fill in our information. So let's start here with completing the square. So we have f of x equals negative 2x squared plus 4x plus 6. I'm going to rewrite this with a little bit of a space, because now I need to complete the square. Now, one special reminder, you cannot have a coefficient besides 1 when you complete the square. Okay, that is a huge rule. Hopefully you remember that, which just means I need to factor it out quickly. Okay, just out of the first 2 terms, and it should look like that. Now I'm going to put in here my b divided by 2 squared. That's the completing the square step. Well, my b value right now is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is plus 1. If you add 1, You need to cancel it out. But wait, did I actually just add 1? No, remember? You had to take out this -2. So I like to put in a dashed or a little dot here to show that in this portion right here, you didn't just add 1. You added 1 that had a factor of -2. So you subtracted 2. To undo a subtraction of 2, you need to add 2. You're like, oh, thank goodness you got us started, right? Yeah, these little things, right? Completing the square has little nuances. Now let's actually see if we completed the square properly, because you should be able to get this term factored into a squared term. So x squared minus 2x plus 1, that actually is the one we had before. This is your function. This is what you're going to graph. You can find the vertex using this equation. The axis of symmetry is going to be x equals something right through the vertex. It's a max or min depending on the direction. So if you open this way, this point is called your max. If you open up, this point is your min, which makes sense. It's your maximum point or your minimum point. X-intercept we found by solving with y equal to 0. The y-intercept you find by plugging in x is 0. Please show all work, all steps, graph it, and I will check this in class. Good luck, peeps.